Hello dear students, welcome back. Now we are going to learn about how to write a balanced chemical equation. The lesson of today is discussing how to write a balanced chemical equation. Well, first of all, we are going to use a simple example about writing a balanced chemical equation relating to the sodium and chlorine atom. Then later we are going to take the advanced part that talks about methane gas and oxygen gas, which is on page 251. Well, okay, assume that I'm having a sodium atom, Na, when it reacts with a chlorine atom, Cl. Well, we know that the atomic number for sodium is 11, and for chlorine it is 17. After making the electronic configuration, you will find that the sodium in that case is going to lose one electron in the outermost energy level, gained by chlorine atom, which is also monovalent, but it's going to gain that electron from sodium. We can say that the electronic configuration is going to be 2, 8, 1, it is 11, and for chlorine it is going to be 2, 8, 7. We will notice that this electron need to be lost and gained by chlorine. Well, in that case, the sodium is going to lose one electron to change to be positive ion. Chlorine is going to gain that electron to change to be negative ion, and the chemical reaction in that gas is in that case is going to give you NaCl, the sodium chlorine chemical formula. Well, in that case, we can say one sodium atom with one chlorine atom, it's going to give you one NaCl. In that case, it's balanced equation. Why it's balanced equation? We just got one atom sodium, one chlorine atom, and we have here one sodium atom and one chlorine atom. We didn't change any structural according to the compound. We still have one sodium atom and one chlorine atom. But notice this, when a magnesium atom takes place instead of sodium atom, which is divalent, positive 2, and at the same time it's positive ion, when it reacts with chlorine, which is monovalent, negative 1, magnesium plus chlorine is going to give you MgCl2, and in that case we have Cl2. Now there is a question. Let's ask ourselves, why the chlorine in that case is 2? Why it's not 1 like here with the sodium? Well, simply magnesium is divalent. The atomic number is 12. After making the electronic configuration, you will find that magnesium is divalent, and in that case it's going to lose 2 electrons taken or gained by chlorine negative ion in that case. Well, we can say that magnesium is going to donate 2 electrons given to the chlorine, and the chlorine in that case will be 2 atoms. So we have MgCl2. We got 1 magnesium and 2 from chlorine needed to such type of reaction. In that case, MgCl2, magnesium chloride. With another example here, the example in the book, when methane gas react with oxygen, CH4 plus O2, oxygen gas, what exactly is going to be produced? Carbon dioxide, exactly, plus what? Plus water, H2O. Well, if we are writing just H2O, now let's talk about that part a little bit. H2O here, just one molecule of water, is continue the equation. We can say that it's a balanced equation in that case. We don't know, let's calculate. We got 2 oxygen atoms, and we have here 2 oxygen atoms. But there, we get another oxygen atom. But in that case, these 2 oxygen atoms is not giving the right amount of oxygen in the reactant. And in the same time, we got here 4 hydrogen atoms. But there, we got just 2 hydrogen atoms. In that case, we need to add 2 here. For the hydrogen to be balanced, we got here in that case 4 hydrogen atoms, we got 4 here. And the oxygen in that case is going to be 2, but the carbon is 1 atom. What we are going to do in that case? Well, we can say carbon is balanced, just 1 atom here. For the hydrogen atom, it is supposed to be 4 like the reactant, and the oxygen atom. What we are going to do here for the oxygen atom in that case? It is not balanced, yes? How we can balance such equation? We can say that this equation is partially balanced. It is not balanced completely. We balanced the carbon, we balanced hydrogen, the oxygen gas not balanced yet. How to write it in a form of a balanced equation? Well, simply the reactant supposed to have 2 from the oxygen molecule in that case, and we are going to write CH4 plus 2O2, that is going to produce what? It's going to produce carbon dioxide gas plus 2 hydrogen with 1 O, that is water in that case, 2H2O in a form of gas. That's it. That's how to balance an equation in as a simplest way as I can, of course. Well, let's find out this part. Okay, concentrate on that part. That figure 1.4. As you can see, we got here CH4, the methane molecule, that is going to react with 2 molecule of oxygen, 2O2, in producing what? In producing carbon dioxide. That's a carbon atom, and that is an oxygen atom. 2 oxygen atom with 1 carbon producing carbon dioxide, and we have here 2 molecule of water, 1 H2O and 1 H2O. Just a chemical formula, it is H2O. We got 2, so we have 2 H2O. In that case, we are heating or using the heat as an effect to produce a chemical reaction between methane gas or methane molecules when they react with oxygen 2O2 in producing carbon dioxide gas and water. 1 carbon atom, 4 oxygen atoms, and 4 hydrogen atoms. As you can see, it is 4 hydrogen atoms. What is going to be produced? 1 carbon atom, 4 oxygen atom, and 4 hydrogen atoms. But in that case, we have a balanced chemical equation, totally balanced chemical equation, and that is supposed to be Bunsen-Burner, using Bunsen-Burner to produce such type of reaction. Well, by reaching that part, dear students, we are finishing the part that talk about balanced equation, and next time we are going to continue with the reversible chemical reaction and the symbol needed in such chemical equation. See you guys.